Next, we need to transform the data into NumPy arrays. So we have to add code, Control MB, and then we will to transform. Yeah, so transform data into NumPy array. So first we have to import NumPy, import NumPy SNP. And then second, labels. Okay, we define labels. So labels are NP array, and then features actual, which is we want to predict. So where labels are what? Labels are the target variable, the target values that we want to predict. And next, we define features. So, well, features equal, from features, we drop actual, right? Because it is target, so we have to drop actual. Actual, and then x is equal 1, okay? Which means the x is 1 refers to columns. 1 refers to columns. And then features are, well, remove the target value, i.e. labels, from the features. Okay. And then what? Feature names. We want to save feature names for later use. Save feature names for later use. So we will feature list. List is basically column names, right? Column names. So features columns. Features columns, right? But I want to save it to the list. Well, labels NP array features actual. Features labels NP array features. Features actual. So there is an error over here. So what we can do is, so actually, yeah, I defined the actual already. So yeah, I want to run this from the beginning again. Okay, now we don't have error anymore. Okay, because, well, I implemented this already. So, okay, so let's add the code. And then features. So actually features, and then NP array features. Okay, I want to make it array as well. Good. Now we define training and testing set. Define training and then testing sets. So in the training set, we will train the model, and in the testing set, we will test. Okay, we will test the model basically. So we will use skit-learn to split data into training and testing sets. Okay. So then we have to import skitlearn. So from skitlearn, okay. From skitlearn, then we will model selection, basically model selection, import, and then train test split to split the data. Okay, and then we split the data into training and testing sets, right? And then we have train features and test features. We have features, right? We divide features into train features and test features. And we also have to divide labels, right? So we divide the train labels and then test labels, right? And then train test split. And then we divide features, and then we also divide labels, and then test size is like 1/4. So we use 25, we drop. We keep 25% of the data for, we drop 25% of the data in training and use that 25% for testing the model. Okay, and then random state so that I can get the same answer as you. Random state maybe 42. Okay. Okay, good. Now we can see the, let's see the tape, shape of all data. Check shapes of all data so that to make sure, so that to check errors, for potential errors, of course. And then we expect, of course, the training features number of the columns to match the testing features number, and then columns. And number of two rows also matches for respective training testing features, right? So, well, let's print training features shape. Training feature shape. And then we can see train features shape. Train feature, train features dot shape. Shape. And then for other, okay. And then we have training labels, shape, train labels shape. Okay. And then we are testing. Testing feature shape. And then testing feature shape, and then test. Okay. And then test. And then testing. Okay, so training features and training label shape 261, they match each other. And testing features and testing labels, they match through 87. And then feature shape 1717, they match. So everything's all right. So we can continue. And then let's regard our benchmark. Let us regard the benchmark or the baseline prediction is average as the baseline prediction. Simple historical average, we can regard that as a baseline prediction. The historical average as the baseline prediction, right? And then our goal is to beat the benchmark, of course. So baseline prediction. We define baseline prediction such that it is the baseline prediction is the test features, and then test features, and then, well, okay, for everything, and we select only average. So feature list, and then the index is average. We select average. Okay, so it is the baseline prediction. So baseline prediction looks like this. So they are the baseline prediction, right? And the baseline errors. And then, of course, there is difference between baseline prediction and test result, right? So it is basically, we regard ABS, absolute value, the distance between baseline prediction and the real data, right? What is the real data? Real data is the test labels, right? So they are baseline errors. And then let's print average baseline error. Errors is, we can simply average that, right? So NP average of the baseline errors. So baseline error is this one. Okay, we have to round. Let's round to the round to 2 second digit. Okay, much better. And then, yeah, because it is degree, so degree. So every baseline error is about 5 degrees. Okay, 5 degrees. And then let's train the model. So the random forest model. Random forest model. Random forest model. So basically, first import random forest model. To do that, we import echelon, and then actually it's called ensemble. It is inside of ensemble, and then well, import random forest regressor. Okay. Okay, good. It works. And then we initiate the model, instantiate the model. Okay. we instantiate the model, and then we have to specify well number of estimators, number of trees in the model. So it is random forest. In the forest, we have to number of trees in the model. Is actually it is called an estimator. And estimators. Okay, so what we can do is random forest is the random forest regressor, and then actually an estimators is, let's say, 1,000 trees. 1,000 tree. Okay, 1,000 tree. Oh, and then so that we can if we want to get the same answer, we have to define the random state. Random state again 42. Good. And then let's train the model. Now train the model with the training set. Train the model with the training set. So we fit the model. So RF fit. Now fit the model. Fit what? Fit features to train features to train labels. Train features to train labels. Okay. Okay, good. Okay, then it is quiet. Okay, so if you don't put comma, you can see the result. Okay, if you put comma over here, it is quiet. Okay, so I want a quiet. Okay, so actually we fit the model. So next, predict in the testing set. Okay, we run the prediction in the testing set. So predictions, our predictions is, so our model name is RF, and then predict. RM predicts, and then we have test features. Test features. So basically what we do over here is the use our forest, use our random forest on the at the testing set. That's what we are doing. So we are running prediction. Okay. So we did a prediction. Now, since we did a prediction, and then we want to see the performance, right? So errors over here, errors is basically the same to this one in the previous one. So it was a test. So instead of we use prediction, our predictions, right? So it is our errors. And then we do the same thing. So it is not based on error. So it is mean absolute, called mean absolute error. So mean absolute error for more rigorous speaking. So it is called MAE. Okay, here it is called also MA, mean absolute error. Mean absolute error. Okay, so mean absolute error for the baseline error was like 506 degree. How about hours? Hours is, it is simply errors. And then degree. And then we can see, so, well, the model is successful. We have like our 4 degrees of it. So our errors are actually smaller. Okay. Okay. So let me check more. Let me check more such that let's more, let's see more performance metrics. Let's see more performance metrics, and then mean absolute percentage error. Mean absolute percentage errors. So MAPE. MAP, we can say MAP. So MAP is basically ratio. Okay, ratio. So the test labels. Okay, MAP errors test labels. Test labels. So something like this. So 이렇게 percentage errors. Okay, and then we multiply of course 100 to make it percent. So for each observation, yeah, for each observation, we can calculate the percentage errors, MAP, and then the accuracy is basically accuracy, because it is error, so naturally accuracy is 100, right? 100 minus MAPE should be the accuracy, right? Accuracy for each one, and then we can get the average. Actually, then we can get the accuracy. So accuracy is like 93%, about 94% of accuracy. So let's print accuracy. So there it is accuracy, and then let's round to the second point, and then let's put percent over here. So our accuracy is about 94%. Okay. Now, one of the advantages of the model is we can interpret the model. So let's interpret the model result. So next, let's interpret model results.